Most people think the biggest challenge for electric cars is the battery. But what if the real problem is something almost no one talks about, something buried deep inside the motor itself? Because right now, the entire EV industry is quietly inked on a material that could disappear overnight. And if that happens, it won't just slow things down. It could stop everything. A few years ago, something strange started happening behind the scenes. Prices of certain materials began jumping unpredictably. Not by small amounts, but doubling, even tripling within months. Car makers couldn't plan. Engineers couldn't guarantee costs. And yet, no one could walk away from it. Because these materials weren't optional. They were essential. Here's the part that makes this uncomfortable. Almost all of it mining, refining, and processing is controlled by one country. And when that country tightens the supply, the entire world feels it. Factories slow down, costs rise, and suddenly the idea of affordable electric cars starts slipping further away. But that's not even the worst part, because extracting these materials comes with a hidden cost most people never see. Toxic waste, polluted water, entire regions becoming unlivable. In some places, people living near these sites are already dealing with serious health problems. And it raises a question no one really wants to answer. If electric cars are supposed to save the planet, why does building them look like this? Now, here's where things take a turn. For years, every major car company accepted this trade-off. It was just the cost of progress. If you wanted efficient, powerful electric motors, you needed these materials. There was no real alternative until someone decided to challenge that idea. Not by making small improvements, not by reducing usage, but by asking a much riskier question: what if we remove it completely? At first, that sounds unrealistic, because these materials aren't just helpful, they're what make modern EV motors so efficient in the first place. Without them, motors get bigger, heavier, and less efficient. Performance drops, range suffers, everything starts to fall apart. So why would anyone even try? Because if this works, everything changes. Costs could drop in a way we haven't seen before. Supply chains would become more stable. And for the first time, electric vehicles might actually become accessible to millions more people. Not just in wealthy markets, but everywhere. But this only matters once you see what happened next. Because this wasn't just an idea, it became a plan. And then, quietly, it became an announcement that most people didn't fully understand at the time. To understand how big this shift really is, you have to go back to the beginning. When Tesla first started building electric cars, they didn't use these materials at all. Their early cars ran on something called an induction motor. It was simple, reliable, and most importantly completely free from this global dependency. But it wasn't perfect. At lower speeds, it wasn't as efficient. It used more energy in everyday driving. And over time, Tesla made a decision that seemed to contradict everything they stood for. They switched. They moved toward a different type of motor, one that did rely on these rare materials. It made sense at the time. The new motors were lighter, more efficient, better for range. And in a market where every kilometer matters, that advantage was hard to ignore. But that decision created a new problem, because now Tesla was part of the same system as everyone else. The same supply risks, the same price volatility, the same environmental concerns. And instead of ignoring it, they started quietly working on a way out. Not all at once, not publicly, just small changes at first, reducing usage, improving efficiency, redesigning components. Step by step, they began pulling away from the dependency. Most people didn't notice until one moment changed everything. At an event that didn't seem dramatic at first, Tesla revealed something that sounded almost impossible. A new motor design, one that would still deliver high performance, but without using any of those materials at all. No dependency, no supply risk, no hidden environmental cost, at least. That's the claim. And this is where the story gets complicated, because removing something is easy to say. Replacing what it does is much harder. The alternative they're working on uses a completely different approach. Instead of relying on extremely powerful materials, it uses something far more common, cheaper, easier to source, but also significantly weaker. On paper, this should not work. A weaker material should mean a weaker motor, less power, lower efficiency, bigger size. That's just basic physics. So how do you get around that? This is where things start to get interesting. Instead of relying on one source of power, The design splits the job into two. One part still provides magnetic force, but not nearly as strong as before. The second part does something more subtle. It uses the natural behavior of magnetic fields, guiding them through carefully designed paths so the motor almost wants to rotate on its own. It's not obvious when you first hear it, but that combination changes everything, because now, instead of forcing performance from expensive materials, the system creates it through design. And if that balance works the way Tesla claims, the result could match or even exceed what current motors can do. But there's a catch, actually. Several. Because outside of controlled conditions, things don't always behave the same way. Heat becomes a problem. Efficiency can drop at higher speeds. And if the motor needs to be larger to compensate, that adds weight, which affects the entire vehicle. And this is where experts start to disagree. Some believe it's possible, but not without trade-offs. Others think the timeline is too aggressive, that scaling this into millions of cars under real-world conditions is far more difficult than it sounds. And they might be right, because this isn't just about making one motor work. It's about making it reliable, durable, affordable, at massive scale, and no one has fully proven that yet. But here's what makes this even more intense. Tesla isn't the only one thinking about this problem across the world. Other companies are working on their own solutions. Some are trying to eliminate these materials completely. Others are reducing them. A few are taking entirely different paths, building motors that don't rely on magnets at all. So now, it's not just a technical challenge, it's a race. And the winner won't just build a better car. They'll redefine how the entire industry works, because the first company that gets this right unlocks something much bigger than performance. They unlock independence. From unstable supply chains, from geopolitical pressure, from the hidden costs no one wants to talk about. And suddenly, the conversation shifts. It's no longer just about range or acceleration. It becomes about control. But even that might not be the biggest impact, because this technology doesn't stop at cars. Think about what happens when you apply the same idea to everything else: robotics, energy systems, machines that need to scale into the millions. All of them currently face the same limitation. And removing that limitation changes what's possible: faster production, lower costs, wider adoption, but only if it works. And that's the part no one can answer yet, because right now, this entire shift is still in a strange place. It's no longer just an idea, but it's not fully proven either. Somewhere between breakthrough and risk. And when it finally shows up in real products, probably in the next few years, we'll get the answer everyone's been waiting for. Not whether it's innovative, but whether it actually delivers. Because if it does, the EV industry doesn't just evolve, it resets. And if it doesn't, then this might end up as one of the most ambitious bets that didn't quite make it. So the real question isn't whether this technology sounds impressive, it's this: when the moment comes, will it actually change everything? Or will it quietly reveal the one limitation no one could engineer their way around? And the moment that answer starts to reveal itself, it probably won't look dramatic. There won't be a headline saying this changes everything. It'll look ordinary. A new car release, a slightly lower price, maybe a spec sheet that most people scroll past. And somewhere in that fine print, a small detail that almost no one notices. But that detail is the whole story. Because if Tesla actually puts this motor into a real production car and it performs the way they claim, it quietly breaks one of the biggest invisible dependencies in modern technology. And once that happens, other companies won't have the luxury of waiting. They'll have to respond. But here's where it gets uncomfortable again, because copying this idea isn't as simple as switching materials. It requires rethinking the entire system: how the motor is designed, how it's controlled, how it behaves under stress. It's not a component change. It's an engineering philosophy shift. And those don't happen overnight. Which means if Tesla gets even a small head start, it could turn into something much bigger over time. Not because others can't catch up, but because scaling a new idea always favors the one who figured it out first. And this is where the story starts to stretch beyond cars. Because the real bottleneck isn't just vehicles, it's production at scale. Imagine trying to build millions of electric cars, millions of robots, massive energy systems all at once while depending on materials that are limited, unstable, and controlled by a single supply chain. At some point, growth hits a wall. And this motor is an attempt to remove that wall before it becomes a crisis. But again, there's a layer here that most people miss the first time. Even if the technology works perfectly,